So I'm Torsten from Aronia. First time you see it. And we are actually designing and producing the spectrum analyzers, including the software. And together with Peter, I think we can show a little bit about site survey. So let's try it again. So here on the left-hand side, we have the 2 gigahertz from the spectrum, and then we are wrapping the spectrum over 4 wraps until 6 gigahertz here at the end. And we can see, for instance, here, this is the 2.4 gigahertz. And here we have the 5 gig channels popping up, so you can see which channel is occupied and which one is running with 4 speed, half speed, and so on. And now we can say, okay, you might have a problem with the interferer, and Peter has a lot of nice toys.
Indeed. So we did this in my CWAP class, and what's really cool is we're now looking at the whole spectrum, something we don't often see. We often just focus on 2.4, 5 gig. So what happens when we turn on a narrowband signal generator is really interesting across the entire spectrum. This is what I would class as narrowband. But actually, what we're seeing?
What we're seeing is a lot of harmonics. So this transmitter is not well built, let's say it that way, because it has a lot of multiple frequencies. So that one is actually my main frequency over here. And then I also have the double of it, and the triple and fourth and so on. And we can see it quite easily. If you shut it on and off, you even see that it takes some time till it locks to the frequency it was made for.
Yeah, there we go, turning it on now.
Yeah, there we are. Yeah.
So that's where it starts, and then we're going to turn it on.
And there we go. So it takes some time, and you see all this shit here is all coming from this unit. So it's really well built for jamming. Let's say it that way.
Okay, so that one's well built for jamming.
Yeah.
I wonder what we'd see if we just looked at a little camera. That would be interesting, wouldn't it? So let me plug in a camera.
Oh, there we go, over here.
So this is a 2.4 gig camera. We can see it in the 2.4 gig band. But then also we see a harmonic of it, don't we?
Right.
At exactly, that's exactly double the frequency, isn't it? So if
exactly.
this is 2.4, that's 4.8.
Yeah.
Which you don't normally see. You see the exact same shape and pattern. If we plug in multiple cameras and turn a few more on,
Yeah, then we really get a mess.
you really get a mess, but can you see what's happening in 4.8? I thought that's really interesting, isn't it? We're not just affecting one frequency, we're affecting the entire frequency band.
Yeah, and look at the channels here at 5. So even those channels are infected in total, even though that we are just transmitting at 2.4.
Yeah, so even 5 gigahertz is being affected by a 2.4 gig cameras.
So even in 6 gig, you will get problems with that because of the harmonics. But of course, they have less power than the main frequency. So 6 gig is still safe.
And I've never seen that before with the tools we've currently used. I've never seen the harmonics in 5 gig from a 2.4 gig camera. So that's pretty cool. What else can we...
Are we seeing Doppler shift as he moves those? I mean, that is incredibly fast.
Oh, it's not fast because it's still in 10 times delayed. So this is the real stuff. So if anybody tells you he has a real-time analyzer, now you've seen it. Because this is sweeping, and this is the fastest in the world. I really believe that, and it's true. So the 3 terahertz, nobody even can come close to that. Even if you go to Rode Schwarz or so, forget it. They don't get it. Sorry for that.
And what would this device do to our spectrum?
Oh, whoa.
Well, what did happen there? But where were we seeing the effect of this sort of wideband signal tester? Because this is a 2.4 gigahertz device, but where else have we seen the effect of it?
There we go. So you have the 2.4 totally blocked,
Yes.
and even beyond it. And you have the harmonic of it. It's over here. So it really shuts everything down, I would say. So I think your 2.4 should be off now.
It should be, yes.
Yeah, hopefully.
Hopefully. We'll turn that one off then and allow some Wi-Fi communications on 2.4 gigahertz. So that's quite cool that we can see the whole spectrum. We can see it so fast. What about actually seeing some of the Wi-Fi
Itself.
itself? Can we see that with a spectrum analyzer?
It just messed up all my little things here. But we can have a look to that one. So that, for instance, is the 2.4 now. And we can get the overlays of the nets. And then we can switch it to full mode, and we see it better like that. So there we get the SSIDs and the MAC address and everything.
You really get appreciation for how fast Wi-Fi is when you're looking at it in real time, how fast frames are going.
We can go to 5 gig now. There we are with 5 gig, and you really see the nets popping up. And what's important is the bandwidth. So now we are analyzing in real time 122 megahertz bandwidth. That means that we can capture frames with 80 megahertz and can decode them. And that's why we get these overlays here. If our analyzer has only 40 megahertz or 20 megahertz bandwidth, we cannot decode those frames. And then we have a problem, of course, that we can't see the overlays. If we go to a higher bandwidth, even 245, I can even decode frames with 160 megahertz. But obviously, there is none here.
No.
But yesterday I've seen some, yeah.
But so you're actually decoding the Wi-Fi data.
Right. So it's so fast that we get every package that's sent over the air and can decode it. And we can record it on disk and bring this record to another environment, let's see, to New York or so, and replay it exactly one-to-one as I would have been on the location where I recorded it. And that's really cool for troubleshooting, jamming. I didn't say that, but but you could do almost everything with it because you can really send those files for troubleshooting. That's really cool. And you have it on disk, and you can record it 24/7, even longer for, let's say, you have a problem that only pops up at midnight on Sunday. How do you know? You only can do it by recording over very, very long time periods.
And therefore, I can look back at my spectral data, but also my Wi-Fi data.
Right.
And I've got both to compare and troubleshoot.
And then you can say, oh, this SSID is entering my net at 12 o'clock. Why is that?
And what about something else you showed me that's really cool? What about if I actually want to see the modulation?
Yeah, if you want to see the modulation.
Because that would be cool, wouldn't it? If I could actually visualize the modulation in real time.
Right.
That's happening.
Where is that?
This isn't rehearsed, by the way.
I do demo.
So I'm sorry for throwing you under a bus.
I try my best. So that's the modulation. This is a QAM 16. That's why we have 16 dots. And if you want to understand how it works, we can add a test pattern over here. So I enter 1, 2, 3 and a 0. And that's the dot 0, 1, 2, 3. So if I enter it, it should be a straight line. It does. And you can see over here that here I have my modulation points as a 3D graph, if you like. And then we can do
You can have all of them on, can't you?
Right. And we can say, okay, I add an F. The F should be on the top right. Enter F. And there we are, and we have my triangle. And what happens if I add noise or reduce noise? I can simulate it here and can see how it's getting blurred and what happens to my transfer. Yeah. And that one is for free, so you don't need the unit. This is a simulation tool. which we have in our software, which you can see over here. So it's simply a software IQ signal generator. And that's...
So if you want to teach and explain modulation,
Right.
you can get your simulation tool for absolutely free.
Sorry for that. Yeah.
That's brilliant. And what about then, I reckon the question that everybody else, what people want to know is, how do I buy this?
Go on our website. So it's
That's
Aronia with double A, and the starting price is around 1,500 euros. But I must say that this unit, from the cost, is about 3,000, and we just give it away to give something back from the earnings we have from the drone detection, because drone detection is our main business where we make the money. And this is just a fun project for the community, let's say it that way. Usually made for the ham radio guys. They said, hey, we need something cheap that's really cool, and we said, okay, we do it. And now I'm here with Wi-Fi, and I see Wi-Fi is even more interesting.
So there you go.
Yeah.
A less than cost spectrum analyzer.
Right.
And the one that goes all the way up till the end of the 6 gig band, that's about another 500, is it?
You can go up to 110 gigahertz if you like.
Okay.
But then, of course, it's not cheap anymore.
No.
But 18 gigahertz, for instance, is a cheap version coming on the market. The 3D. Oh, what else do we want to see? My God. Wi-Fi interaction.
Is the storage local or is it cloud storage? We talk about recording stuff.
It's no cloud, it's offline.
No cloud here.
Yeah. So there we go. Just bring the graphs in one that we see it better. So that's the 3D you wanted to see, right? So this is the Wi-Fi and Bluetooth popping up. But again, this is not real time. If you want to see it real time, this is the real time. And we can simply pause it and say, look, this is my Bluetooth capture over here. This is the Wi-Fi, the start of the Wi-Fi and the package itself. And then we can go over with the cursor with a block, which is not free, where you can decode the frames.
And you can even measure how long that transmission took.
Right.
So you can see how long it actually takes to send a frame.
Yeah.
How cool is that?
So there, for instance, we have the waterfall from the top.
Yeah.
And you can see here is my frame, my beacons. Here I have data transfer. Here I also have data transfer. And all those little blips here is all Bluetooth. We even have some channels which we can add on the bottom. Of course, this is a fixed list.
So that's like a BLE channel.
Right.
Yeah.
And you have another one here.
And another one there. So they're your free BLE advertisement channels.
Right.
Which you can see transmitted.
And it's still not real time, as you can see, because it's factor 10 compressed. Now we have real time.
Oh, that's real time, yeah.
Sorry. So there we go. Okay.
Cool. Thank you for showing us that.
Yeah, welcome.